So I know that a few people on Instagram and YouTube have asked me to do a follow-up on my first video showing my initial tests of the Arduino launch control that I've been working on. So I thought I'd just do a quick video to describe how I went about it. I actually got the idea to do this after removing a piggyback ECU called a Unichip, which was causing some fueling and timing issues on my car. When I deleted it, I actually found that it was tapping into the IGT, TPS and AFM signals on the ECU, which was lucky for me since the harness they added gave me an easy way to tap into the wires, which I pretty much wouldn't have done otherwise. This sort of made me think, okay, well, if I can control the ignition timing through IGT, I had no idea what IGT was at the time. I could probably build a module that runs off the 12 volts going to the ECU, and if the IGT signal is 5 volts, I could probably also measure and manipulate that. So after a bit of Googling and some research, I found that luckily the IGT line, which is common on these sort of older Toyota models, actually does run on 5 volt TTL logic. So I thought, well, what do I have that can prototype with a 12 volt supply and use 5 volt logic? And I decided on using an old Arduino Nano that I had lying around. So the Nano is quite cool for these projects because it's obviously very small, has a built-in voltage regulator rated to over 12 volts, and it's programmable over mini USB. Just sort of looking at the IGT signal from some old Toyota documentation, it was pretty clear what IGT was actually used for, and it's basically just a control for the ignition coil charging, and it also consequentially determines when the spark plugs are fired. So on my car, that's how the timing is retarded or advanced, even though it still has an old school distributor. With that all in mind, I started trying to find some examples online of how exactly to determine engine RPM from IGT, because I didn't want to splice into any of the other ECU wires that might be better suited for reading RPM. I couldn't really find anything that could give me a formula for calculating it. So on a normal 4-cylinder like the 3S GTE, the spark plugs fire at a rate of 2 sparks per revolution. And because we know these sparks happen when IGT is falling from high to low or from 5 volts to 0 volts, it's pretty easy to determine the duration of the falling edges. So I basically just set up the Arduino to measure the length of time between the falling edges and therefore get the duration between sparks. Basically used a formula for determining the RPM. So the formula is quite straightforward to figure out. Now that I know the RPM, I can go ahead and start implementing the rev limiter. So it's actually pretty simple. I have the IGT hooked up to a digital input, which is then set up with a interrupt, and that interrupt is triggered whenever the line is falling from high to low. So using that and the micros or millis function of Arduino, it's pretty easy to determine the pulse width, and using that formula, it's very easy to determine the RPM. So basically all this system does is constantly reading the RPM, and you can just cut the spark using a relay. So I just use a pretty normal off-the-shelf relay. It's controlled by a input line, which you basically just pull to ground. Obviously, you can use a delay to basically control how hard the rev limiter is. You can have it with quite a high frequency cut, which sounds basically like a factory rev limiter. If you slow down the gap between cutting the spark and allowing the spark, you can actually go into a condition where the spark will ignite leftover fuel that hasn't been ignited in the previous combustion cycle and get flames to shoot out of the exhaust. And yeah, that's basically it. I'll probably be posting the source code in the video description at a future time. For now, I'm still refining the circuit, and I'm in the process of routing it into the cabin so that I can use it there. But because you are using an Arduino for this whole project, and you still have many input and output pins available on the Arduino Nano. It's pretty easy to think of a couple of creative ways to use this or further interface with the car. So some other ways you could interface would be to tap into the TPS signal to adjust how hard the cut is based on where your throttle is. Another use case you could do, which is something that I'll probably look at doing in the future, is hooking it up to the handbrake switch as well. So you have the launch control activate every time the handbrake is up. Obviously, because it's an Arduino, the sky's the limit in terms of what you can program in. You can control the rev cut to do whatever you want it to do. So if you have any questions about anything in this video or about any of the wiring or programming, you can just leave a comment at the bottom of this video.